Yeah, thanks. So the 274 centimeters, this was derived from the insulation coordination study that we are discussing in our next classes, which depends upon the BIL level of the system, like the lightning impulse voltages and switching impulse voltages. So how we got this 274, the derivation I will explain there in the insulation coordination study. So the spacing was there. And I am calculating the short circuit forces, the maximum short circuit forces. So the maximum short circuit forces is 195.8 Newton per meter. And I am calculating the bus conductor loading also. I am just assuming the thickness of the ice is 1.2 centimeters. This I am generally we will get from the NESC loading data. You can, if you Google it, you can get those documents. And the pressure is this based upon the wind zone. So the total resultant force is this. Now I am substituting this value of resultant force on the support spacing, and I am calculating the maximum bus support spacing, which is coming to 12.48. But in the assumption, for the equal spans, I assumed 11.43, which is less than the required 12.48. So already I selected which is assumption is quite good. 11.43 is a fine formula. And I am calculating the deflection one. So I am calculating the deflection. What is calculating the maximum vertical conductor deflection? This is generally depends upon the conductor weight and the conductor weight and the ice loading, which is acting on from the top, and the span one. So since I calculated the deflection, so from this the maximum permissible deflection is 1/200 of the span length, which was mentioned in the IEC one. So, but my deflection is 10.71. If I am calculating since calculated deflection is greater than the maximum permissible deflection, the design has to be modified. The span length will be reduced to 5 equal spans of 19.14. Then the maximum vertical deflection is then recalculated, which is 4.14 centimeters. Now the maximum permissible deflection, if I am calculating, which is 4.57 centimeters. Since the calculated value with 9.14 meter support spacing is less than the maximal permissible deflection, the support spacing is adequate. Means now before what I done in this example with this support spacing, I concluded that 11.43 would be the sufficient for in this case for the supports. But maybe if I am placing that, maybe due to the wind loading and the conductor weight, there might be a deflection from the top. The conductor, it would be, maybe it will bend or it will move towards this. So such cases will occur. So generally, as per the guidelines, it was said that the maximal permissible deflection is 1/200 of the span length. So it is not attainable with this 11.43. So now I decreased the span length. Now I made 5 equal spans of 30 feet one. So by this, I am attaining this one. I am attaining this. So that is the deflection factor. So after that, by this, I concluded the spacing. Now the spacing is 5 equal spans. Each span is of 9.14 meters. Now I am calculating the cantilever strength, which is the minimum required support insulator cantilever strength. Depends upon the short circuit force and the wind force and into this span length, which is 9.14. So this is the 5 kN. So I can select the 5 kN post insulators. And I am calculating the thermal expansion. Thermal expansion depends upon the factor of delta T. Means delta T is temperature variation. From this temperature variation, I am calculating the thermal expansion. So based on this thermal expansion, I have to provide the couplers. So coupler location. Locate the conductor couplers. How I am locating? From the table 4.413, generally, here before also I didn't explain you about the couplers. Generally, as the temperature of the conductor increases, suppose the conductor temperature increases, longitudinal expansion occurs. If the bus system is not provided with means to absorb this expansion, insulators on other connected equipment may damage. Means this is now connecting to some other equipment, right? Like isolators or maybe to the some other equipment. So that may change if you not provide a sufficient provision to for expansion. So a wide range, a wide temperature range is required to accommodate the bus length when de-energized at the lowest design temperature up to the maximum bus operating temperature. So we need to provide a couplers which will act like a kind of expansion between the expansion. I will show you in images here. So for the long buses, usually require the use of more than one section of conductor. As I said before, the conductors cannot be available as we like 50 meters or 40 meters. Generally, the conductors are of some 3 meters long, 6 meters long. So couplers have to be utilized to join the sections together. Like to join this section to this section of conductor, we require these couplers. And these couplers are also have properly located to prevent the damage from the bus loadings as well as the short circuit forces. So how to place this coupler is derived in the table 413, where mostly the couplers we are taking from the right to the left to the right. I will show you then that one to make you better understanding. Let's see here.